Assalamualaikum warahmatullahi wabarakatuh. This is my report about measure of dispersion. We have two types of dispersion. Number one is measure of absolute dispersion. The actual variation or dispersion determined by the measure of absolute dispersion is called absolute dispersion. It means the simple measure of absolute dispersion is the range. This is just the upper limit minus the lower limit, the largest data points minus the smallest. We can write this as range equals to upper limit minus lower limit. Like for instance, if a data set considered of points 2, 4, 8, and 18, the range will be 18 minus 2 equals 16. So in other words, ang pinakamalaking given na number ay ima-minus sa pinakamaliit na number. That's the simple example of absolute dispersion. Number 2 is measure of relative dispersion. The measure of absolute dispersion cannot be used to compare the variation of two or more series. Best example of relative dispersion: if a data set consisted of points 2, 4, 5, 8, and 18, the range will be 18 minus 2 equals 16. The analogous relative measure of the dispersion is the coefficient or range. This is given by highest number minus by lowest number. After that, you are going to add highest plus lowest number. For our example dataset, it will be the ratio close parenthesis 18 minus 2 open parenthesis equals 16. Close parenthesis 18 plus 2 open parenthesis equals to 20. So it could be close parenthesis 16 divided by 20 open parenthesis. After that, you are going to divide 16 and 20 like this. 16 divided by 20 equals 4 divided by 5 or over 5.
Good day, ma'am. I'm Ashnalia Mangakop, and now let's proceed to the types of absolute dispersion. Letter E is the range. Range is the simplest measures of dispersion. It is defined as the difference between the largest value and the smallest value in the data. For example, in 4, 6, 9, 3, and 7, the lowest value is 3 and the highest is 9. So the range is 9 minus 3 equals 6. For group data, the range is defined as the difference between the upper class boundary of the highest class and the lower class boundary of the lowest class. So according to the definition, the range is defined as the difference between the upper class boundary of the highest class and the lower class boundary. Like for instance, 0 minus 10, 10 minus 20, 20 minus 30, and 40 minus 50. Range is calculated as 40 minus 0 equals 40. Letter B is the quartile division. It is known as the semi-interquartile range. The range is a poor measure of dispersion where extremely large values are present. The quartile division is defined half of the difference between the 3 and the first quartiles. Number 2, the difference between the third and the first quartiles is called the interquartile range. Example, if the given number is 22, 12, 14, 7, 18, 16, 11, 15, 12, you are required to calculate the quartile division. So first, we need to arrange data in ascending order to find Q3 and Q1 and avoid any duplicates. 7, 11, 12, 13, 14, 15, 16, 18, 22. Calculate of Q1 can be done as follows. Q1 equals 1 over 4, open parenthesis, 9 plus 1, close parenthesis, equals, you have to copy the 1 over 4, and then 9 plus 1 equals 10. After that, 10 divided by 4 equals 2.5. So Q1 equals 2.5 term. Calculate of Q3 can be done as follows. Q3 equals 3 over 4, open parenthesis, 9 plus 1, close parenthesis, equals, we are going to copy the 3 over 4, and then 9 plus 1 equals 10. 10 divided by 4 equals 2.5 times 3 equals 7.5. So Q3 equals 7.5 term. So letter C is the main division. It is defined as the average of the divisions of the values from the average. It is also known as absolute division. So here is the formula. The sum of all absolute division from the main x bar divided by n. So for main division is an arithmetic mean of all absolute division from the main. This is sum of all absolute division from the main x bar divided by n. We are going to find the mean of the data, which is mean, which is the sum of all absolute data. We have divided by the number of data, and this be equal to 8 plus 9 plus 10 plus 11 plus 12. So if we add this together is equal to 50 divided by 5, and equal to 10. The main x bar is equal to 10 for this distribution. For main division, we are going to apply this data. We say 8 minus the main, which is the x bar 10. We take the absolute bar, we add 9 minus 10 absolute value plus 10 minus 10 absolute plus 11 minus 10 absolute form, and the last one is 12 minus 10 absolute form, all divided by the number of times we have, which is 5, equals 8 minus 10 is negative 2 in an absolute value. We are going to be positive 2 plus 9 negative equal minus 10 negative 1, but then absolute form, which is going to be positive 1 plus 10 minus 10 equals 0, plus 11 minus 10 is 1, plus 12 minus 10 equals 2. So the total is 6 over 5, which is equal to 1.2. The main division of the set of the data is 1.2. And the last but not the least is the standard deviation. Measures the spread of the data about the main value. It is useful in comparing set of data which may have the same mean but a different range. For example, the mean of the following two is the same: 15, 15, 15, 14, 16, and 2, 7, 14, 22, 30. So that's all for the types of absolute dispersion. And now let's move to the types of measures of relative dispersions. Number one is the coefficients of variation. A coefficient of variation can be used to record changes in data over time and aid in business decisions. Investors use these calculations to determine risk and reward within prospective investments. Calculating the coefficients of variation is simple with a standard formula. In this article, we discuss what a coefficient of variation is, how to calculate it, and provide examples on how to do. Like for example, in stock investments, to calculate the coefficients of variation in her potential stock investment, Jamila inputs her volatility percentage of 7 and her expected return percentage of 13. Stock investment coefficient variation equals 7 divided by 13 times 100%. Divide the volatility and return first. Coefficient variation 0.5385 times 100%. So coefficient variation equals 0.5385. Convert the answer into a percent by moving the decimal 2 places to the right. So coefficients variation equal 53.9%. So that's the simple examples of coefficients of variation. Next is the coefficients of dispersions. If xn and xn are respectively the maximum and the minimum values in a set of data, then the coefficients of dispersion is defined as coefficients of dispersion equals xn minus xn over xn plus xn times 100. So that's the way how to solve coefficients of dispersions.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Nuraima Pinagayaw. Quartile coefficient of dispersion. Quartile coefficient of dispersion is a descriptive statistic which measures dispersion and which is used to make comparison within and between data sets. Quartile coefficient of dispersion is a measure of the spread of a data set. The formula is Q3 minus Q1 over Q3 plus Q1. The example of quartile coefficient of dispersion is: what is the quartile coefficient of dispersion for the following set of numbers? 2, 4, 6, 8, 10, 12, 14. Step 1. Find the 25 percentile Q1 and the 75 percentile Q3. There are a few ways you can do this. One of the easiest ways is to use our interquartile ring calculator. Then, finding quartiles. Q1 equals 25 percentiles is 4. Q2 equals 75 percentile is 12. Step 2. Plug the number from step 1 into the formula and solve. Q3 is 12 minus Q1 is 4 over Q3 is 12 plus Q1 is 4 equals 12 minus 4 equals 8. Then 12 plus 4 equals 16. Then 8 divided by 16 equals 0.5. The coefficient of dispersion for this data set is 0.5. That is the example of quartile coefficient of dispersion.